Continuing the tour of the SMARTFIRE environment, we now consider the SMARTFIRE mesh generator for a structured mesh. The output from the structured mesh will be the command script file and the geometry file, which can then be taken forward to the CFD simulation. In order to generate a mesh, which is the next task in generating a scenario, we go to the Run option and Create Mesh. The meshing system in SMARTFIRE has a number of rules built into it and will perform a number of checks of the geometry to enable the best quality of mesh to be produced. First warning that's come up is that there are overlapping objects, and this is known because we have inserted objects which are in the same coordinate positions, and this is a known acceptable situation that we've intended, so we can ignore these overlaps and proceed to meshing. The meshing system now tries to understand the nature of the geometry so that it can apply the best sort of rules for meshing. In this case, based on the size and complexity, it thinks that the closest to match is a standard room geometry, but if you thought that actually you're generating something else, by all means select the most appropriate from the list below. In this case, I'm happy to use the standard room geometry rules, so I can select OK. The meshing system now moves on to considering extended regions, and extended regions are required outside of vents. So we define the geometry inside the region boundaries. Any vents require extended regions outside in order to allow the flows through those vents to be computed accurately. In this case, you have no option about the x high and z high directions, but if you wanted to, if it was important to you, you could add additional extended regions in the other directions in order to allow for better modelling of flows outside of the building that you're considering. In this case, I'm not interested in creating any external extra regions, so I will accept those ones that I have to apply. The next task is to set the cell budget selection for meshing. In most cases, you'll want to use the recommended refine. If you want the case to run very quickly, you may choose a coarse mesh without refinement. Generally though, it's best to use the recommended options. So recommended refine is selected, and that generates a first pass mesh. At this stage, the meshing system becomes a manual meshing system, and if you now want to change any of the cell numbers in any of the region blocks, you can do so by selecting on the block and changing the number of cells. If any particular region does not seem to have a very good quality mesh, you can also change the meshing type. So for example, this block here has a growing in the middle type of mesh between the lower Z and the higher Z region limits. So in this case, it may be better to apply an even mesh and reduce the mesh budget slightly. Remember now that we're not seeing just the region that we defined earlier and the geometry that we entered, we're also seeing the extended regions. So we have the extended regions to control in terms of mesh budgets as well. It's always worth considering the quality of the mesh and watching for very long, thin, narrow cells or very small cells adjacent to very large cells, because these may have a negative impact on the quality of the simulation that you produce. So always be aware of the quality of the mesh when you're actually going through this stage, and do question the mesh that is created automatically, because the meshing rules do not always perform optimally when there are certain complexities in the geometry. When you're happy with the mesh that has been specified, you can select Accept, and that will create the command script file, the geometry file, which can be taken to CFD simulation.